Okay, let's do some practice problems. Assign oxidation states to each element. So in all of these compounds, ions, polyatomic ions, we need to assign oxidation states using the oxidation rules. Remember, we have 8 rules that we'll fall back on. If the atom that we're interested in isn't listed in those rules, we need to deduce what it would be. All right, so do one at a time here. So now hydrogen in a compound is a positive 1, but an atom in its elemental state, hydrogen is diatomic, its oxidation state will always be a 0. Now hydrogen in a compound, it'll almost always be a positive 1. And oxygen will be a negative 2. Okay, now hydrogen and oxygen, as it turns out, are your best friends with this. They're the most common elements by far, and so assigning hydrogen a positive 1 oxidation state and oxygen a negative 2 in many of the compounds, as we'll see, will help you figure out what the other oxidation states are. Okay, iron is just the atom, no charge on it, in its elemental state, be 0. Monatomic ions, whatever its charge is, it's going to have the same for its oxidation state, positive 2. Okay, now here, nitrogen, there isn't a rule for nitrogen, but we can deduce what nitrogen's oxidation state is by looking at hydrogen. We know that hydrogen's oxidation state is a positive 1. And since there's 3 of them, that must mean that the oxidation state of nitrogen must be a negative 3, so that when we add them together, the sum of their oxidation states will be equal to 0. And that'll always be the case for a compound. So the same thing here, oxygen is a negative 2. There's 2 of them, so it must mean that the sulfur is a positive 4. 2 times a negative 2 plus a positive 4 is 0. Now, just in passing here, remember that this is not peroxide. Peroxide would only occur when you have oxygen bonded to a very electronegative, or I'm sorry, to a very reactive metal like a group 1 element. Sulfur is not a group 1 element. So again, for as far as it being concerning yourself whether it be peroxide, it just isn't. It's rarely going to be, unless it's one of the group 1 elements, it's not going to be peroxide. Group 1 elements that it's bonded to. Okay, now for carbon tetrachloride, neither one of them has a rule in the oxidation rules. Neither one of them is specifically mentioned, but I think that maybe this is the very one that we had in the example for the rules. Chlorine is the more electronegative element, and so when it becomes an ion, it has a negative 1 charge, so that is its oxidation state, negative 1. There's 4 of them, so carbon must have the oxidation state of positive 4. We add them all together, we get 0. And now for polyatomic ions, when we add together the oxidation states, it needs to equal the charge of the polyatomic ion. So again, oxygen is a negative 2. There's 3 of them, so that must mean that the nitrogen has the oxidation state of positive 5, so that when we add positive 5 plus a negative 6, we get a negative 1, the charge on the ion. Okay, for permanganate, oxygen has a negative 2. There's 4 of them, and so the manganese must have a positive 7 oxidation state, so that when we add a negative 8 and a positive 7, we get a negative 1. For chromate, oxygen is a negative 2. 4 of them, so that it'll give you a negative 8. So the chromium must have a positive 6 oxidation state, so that when we add them all together, we get a negative 2. Okay, magnesium bromide, well, these are really quite easy because this is an ionic compound. And so all you need to ask yourself is, well, what are the charges on the ions? Magnesium is positive 2, and bromide is a negative 1. You knew that from last year, first year chemistry. Okay, now for hydrocyanic acid, hydrogen is a positive 1, but we don't know, we don't have a rule for carbon or nitrogen. So this is like the carbon tetrachloride. We're going to look at the 2 nonmetals and determine which of them is the more electronegative. Nitrogen is more electronegative than carbon. So when nitrogen, so you ask yourself, when nitrogen becomes an ion, what charge does it have? It has a -3 charge. So its oxidation state would be a -3. So that means that we can deduce what carbon's oxidation state is by simply seeing what it would have to be so that when we add up all the oxidation states, it equals 0. So it must be a +2. So +3, -3 equals 0. Okay, now we're going to look at some chemical reactions and see which is oxidized, which is reduced, what is the oxidizing agent, and what is the reducing agent. So hopefully this will make a lot more sense after we work through these. Okay, now the first thing you need to do is assign oxidation states to everything. So sodium is the oxidation state of a +1. Oxygen is a -2. Hydrogen is a +1. On the product side, hydrogen is diatomic in its elemental state, so it's 0. Sodium is +1. Now this is an ionic compound, so sodium hydroxide, sodium's an ion, +1. Oxygen is going to be a -2, and hydrogen a +1. Notice when we add those together, we get 0. Okay, now this, by the way, is the homework that you're going to be asked to do. You're going to need to determine the oxidation states of everything and then determine what is oxidized and what's reduced, the oxidizing agent and reducing agent. All right, now to determine which is oxidized and which is reduced, it's really easier to first determine what is reduced, because the term reduced, simply just think of that, the number needs to go down. And so which element has an oxidation state that goes down? Well, sodium goes from a +1. Boy, I'm sorry, I made a mistake there, didn't I? It's not +1. It's 0. I don't know. Can I edit that out? I think I might leave it in. Sodium is 0. So sodium goes from 0 to +1. So its number didn't go down; it went up. So sodium, as we'll see, undergoes oxidation, but hydrogen goes from a +1 to 0. So its number is reduced. So hydrogen is reduced. Its oxidation number goes down. Now notice that you also have hydrogen over here that's still +1, and that's quite often the case where you'll have the same element being reduced or oxidized, and then the same element where nothing happened at all. So that's not unusual. Okay, now sodium went from 0 to +1, so its oxidation number went up, and that's the case of oxidation. All right, now to determine what is the oxidizing agent, we need to answer the question, what did sodium have to react with in order to be oxidized? Well, sodium reacted with water. It didn't react with hydrogen, it reacted with water. So water is our oxidizing agent. We write down the entire reactant, in this case water, not the element, but the reactant. And then hydrogen was reduced. What caused hydrogen to be reduced was reacting with sodium. So sodium is our reducing agent. Again, notice when we identify what is being oxidized and what is being reduced, it's just the atoms themselves. For the oxidizing agent or the reducing agent, it's the reactant itself, the whole thing, whatever it might be. All right, so let's do next one. Now you can stop the video here and try it yourself and then come back. But I will do it right now. All right, so hydrogen is +1. So carbon must be a -4. Oxygen is 0. Carbon, well, oxygen is a -2. So carbon a +4. Oxygen -2. Hydrogen +1. So if we look to see which number goes down, which is reduced, well, carbon goes from a -4 to a +4, so that goes up, so it's not yet, but oxygen goes from 0 to -2. So it went down, so oxygen is reduced. Carbon, its oxidation number goes from -4 to +4, so it's being oxidized. So its oxidation number goes up. Now, what caused carbon to undergo oxidation? Well, it was reacting with oxygen, O2. That's the reactant. So O2 is the oxidizing agent. And you might see now why when we say something is oxidized, quite often oxygen is the agent that caused that to occur. The oxidizing agent is oxygen. The reducing agent, what caused oxygen to undergo reduction? Well, it was reacting not with carbon, but with methane, CH4. Okay. All right, one more. Again, you might want to pause the video and try it yourself. All right, I'll do it now. Okay, now this is an ionic compound, so again, it's really easy. You just ask yourself, what is the charges? Well, aluminum would have a +3 charge, and oxygen a -2. Oxygen -2, so it must mean that carbon is a +2. Aluminum, atom in its elemental state, 0. And carbon dioxide, oxygen's a -2, so the carbon must be a +4. Right. So aluminum went from a +3 to 0. So aluminum was reduced. And carbon went from a +2 to a +4. It increased, and so it was oxidized. What caused the carbon to be oxidized was reacting with aluminum oxide. So aluminum oxide is our oxidizing agent. And what caused the aluminum to be reduced? It was reacting with carbon monoxide. All right, now this is what you're going to be asked to do on the homework. There's another video to watch that kind of gives you a head start on doing those problems. All right, that is it.